Now this is about the only case for matrix transformation. Okay, I'll just give you the list of things we're going to deal with in matrix. 1 minute. I need to open a different file. Let's first understand what are the things we're going to come across in matrix. In matrix, mostly in paper one, you will not see any kind of transformation or translation. Okay, in matrix paper one, you'll only see multiplication. I mean, at this point in IGCSE for your new specification, they do not actually include multiplication that much. I mean, multiplication is like very easier concept for them at this point. But still, I'm writing it down that multiplication is there. Then I think we have subtraction addition. I'll just write subs and addition. After this, we have this determinant. And inverse. Okay, these are the things you will see in your paper one matrix, and in paper two matrix you will see enlargement. Then again you will see what else? Yeah, enlargement, enlargement. Uh, sorry, I was saying that enlargement, transformation, stretching. These are the things you see across in paper two. So in paper two you will see enlargement, part two stretching, and for part three we're going to see transformation and translation. And translation is actually the word translation. Okay, these are for your paper two. Paper two is basically tough. They will contain, like this kind of paper two maths will contain at least 10 to 12 marks. Okay, and in paper one, I mean they are also important, but in maximum they can contain like 6 to 5 marks at the maximum point. But other than that, paper two matrix is mostly important. Let me just write it down over here. This is matrix one. Now, again, after this, we are going to start with the matrix worksheet. I've already provided you with the PDF in your groups, and we are going to solve that today. And again, we're only solving paper two matrix, that is enlargement, stretching, translation in today's class. Okay. So this is the final paper, and we're starting from this question. Now, in question one, I think this is Himika, right? Yeah, I mean, Panda is Himika. Okay. Then in question one, this is how the question will actually appear. Like you can count the numbers 3, 5, 7, 10. So this is a 10-mark question. This is how a diagram will be provided to you, and you need to rotate it for some point. You might need to enlarge it. You might need to squeeze it or compress it. Okay, enough jokes. Now we'll start from here. Now it says that trapezium P and Q that are already drawn on the opposite grade, like this is trapezium P and Q. Okay, this is trapezium P and Q. We can clearly see that trapezium P and Q are quite similar, whereas P is a smaller version of trapezium Q, but they're not exactly aligned on same space, right? They're on different positions. Now then again one thing, how can I understand the coordinates for this? For example, I am going to write, I just want to, like labelize the coordinates over here. For example, this point has a coordinate of 4, 4. Okay, this has a coordinate of 4, 4. You take the x-axis reading and you take the y-axis reading. So 4, 4 for that point. And then again for this point, as this is exactly on y-axis, always remember at y-axis, x is equals to 0. At x-axis, y is equals to 0. That means for this point, coordinate is 0, 6. Right? X-axis coordinate is 0, y-axis coordinate is 6 for that point. And again for this part, x-axis is -2, so it's going to be -2, 6. And for this part, -4, 4. So this is -4, 4. Similarly, I need to find out the coordinates for that trapezium P also, which is going to be 5, 1, 5, 1. This is 3, 3, 2. Right? Yeah, 3, 2. And this is 2, 2. And this is 1, 1. Is there anyone still having any confusion how I'm labeling these coordinates over here? Any problem? Also, let me remind you guys that I'm going to upload these videos in YouTube also. Now, this is how you're going to write down the label, like the coordinates for this trapezium Q, trapezium P. So this is the arrangement. You can clearly see the x-axis goes on top and the y-axis goes on the bottom. And then similarly for trapezium P also I'll do the same working. If there is any problem you guys cannot understand, certainly I can speak in Bangla in between. Okay, no problem with that. And again, one thing you have to understand that I started from this part for particular trapezium Q, right? This one, this one, this one, and this one. So from here also I'll start with the same orientation. I'll start from here and move in an anti-clockwise to this part. So it will be 5, 1. Sure, you can, but in most cases in question papers, they will actually give you these graphs, okay? But obviously, if you're going to use your phone to solve this question paper, certainly you can use the graph booklet. Okay. Now, first thing first, always when you're going to start with this kind of matrix questions, we are going to label the points at the first, okay? Like find out the labels of every coordinates for any kind of structure they have provided. Okay. Now we'll move on to the main question. For example, it says that describe the single transformation that maps trapezium P and Q. Now, as I've already stated that, okay, I can clearly understand from the diagram that they are quite similar, right? I need to explain that how they are similar. I've already stated that trapezium P is a smaller version of trapezium Q. So I can say that trapezium P, so trapezium Q is an enlargement of trapezium P, right? Enlargement means that you're going to extend that. You're going to make it bigger. So you can say that trapezium Q is an enlargement of trapezium P. And enlargement also has to be given with some data, like by how much units that trapezium Q is longer or larger than trapezium P. That unit is referred to as scale factor. Like by how much unit trapezium Q is larger than trapezium P, that is what refers to your scale factor. So scale factor can be counted by using this. Always measure the horizontal or vertical or straight sections of this kind of diagram. For example, over here you can clearly see you have 1, 2, 3, 4, 4 units, right? And for this trapezium Q, you're going to have 1, 2, 3, 4, 5, 6, 7, 8, right? So 8 units. The trapezium Q is 8 units longer. Trapezium P is 4 units longer. So for part A, I'm going to write the answer for part A over here. I'm going to write it down as trapezium Q is an enlargement of trapezium P. Another thing to mention over here, you are saying that trapezium Q is an enlargement of trapezium P. That means P was on the situation first, and then modifying P, you got Q, which actually indicates you are actually referring the object like trapezium P as the object, and by modifying trapezium P, you got the image, which is trapezium Q. Okay. So this is your object P and image is Q. And now again, I was trying to find out the scale factor by how many units trapezium Q is longer than trapezium P. I can calculate that using this formula. Scale factor is image over object. Okay. Now scale factor, I'll just write down a scale factor as SF over here. And image was, if you remember, image was Q, which is 8 units longer, and object was 4 units longer. So you can just write 8 over 4, which is 8 over 4, that is 2. Another thing, you need to find out the center of point over here also. Like always, there will be a point through which this enlargement is occurring. We got this scale factor, right? No problem with that. But now we find out the center also. For that center, I'm going to erase the coordinates over here. They are not needed anymore. I've already listed down the coordinates in this section. So I can use it later if I want the coordinates from that list. I do not need the diagram. Now, in this case, how do I understand if they have a certain point or not, if they have one point common or not? Hmm. That is, I'm going to try to connect all the lines together. For example, this point, I'm going to connect this point. Right? This is one of the straight lines that can be created. I have to modify a little bit. Okay. So then again, I'll try to connect another points together. For example, this one will be connected with this one. Just 1 minute, I'll modify it. Obviously, these are like what? Imaginary lines, right? So always remember, whenever you are going to draw imaginary lines, obviously I do not have scale, right? That's why I'm using auto correction. So in auto correction, I cannot draw broken lines. That's why I'm drawing solid lines over here. But on your diagram, this lines has to be drawn on your diagram also. This is a part of your working. You cannot just erase it after you're done with the center calculation. Okay, so you have to draw these lines using broken line. I hope all of you know broken line has to be drawn like this, like dotted lines or broken lines. Okay. Now I'm going to carry on the same procedure. I can clearly see both the points are kind of intersecting, like both the lines are intersecting at 6 minus 2, right? But let's just get assured by connecting all the other points. So another line and another line. We can clearly see all the points are actually coming together at 6, 2, right? 1 minute. Yeah, everything is coming in contact. 1 minute. Hmm. Everything is actually intersecting at this point, which is what? 6 minus 2. In that case, there is an enlargement of scale factor 2 and with center 6 minus 2. Right? So at the end, we're going to write that's enlargement scale factor. Center was 6 minus 2. Is this clear? Any question till now how we understood the transformation from trapezium P to Q? Any question for this diagram?
No.
Himika, Isfa, do you guys have any problem?
No, bro.
Okay. I'll just take a screenshot of this and then we'll continue because maybe I'll need the same diagram for different cases. Okay. I'm just going to like erase it. Another thing to focus over here that you can clearly see that both the image, this was the image, this was the object, right? They were what? At same side of the scale factor, right? Sorry, center. This is your center, and image and object both were in the same section, same side of the scale factor. But if the case was not like that, maybe there could be another cases where the center was over here. 1 minute. Where the center was over here and the image was on this section, object was on this section. This is image, this is object, right? This is a case, this was your center, right? Through which any kind of change has occurred. Now, in this kind of situation, when your image and object are on opposite sides of the scale factor would be negative. Okay, there's one note to be taken that when image, first one is when image and object are on center, scale factor is negative. Okay, and the opposite of this will be when image and object are on same side of the scale factor, center, scale factor would be positive, right? So I'll just copy this same statement. Are on same sides of scale factor, center, scale factor is positive. This is a very important thing. This is also written on your formula booklet. So okay, I would suggest after this class, go through the list of formula that is written on your formula booklet for that matrix part. And for ISFA, I'll send you the PDF of the formula booklet so that you can read that right after the class. Okay, I think this is quite important, but I won't actually have much space for it. Okay, I'll just copy it and write it at the very bottom, and then I'll see where I can fit it at the very end. We're going to try to solve this entire worksheet within today's class. Let me see how much we can finish. Okay. Now, okay, again, over here, if you remember on your diagram, this was your center and your image and object both were on the same side. So scale factor over here is going to be positive, right? That's why you got positive scale factor 2. Minus will not be involved. Okay, this was your entire working for part A. We're going to move on to part B. It says that trapezium B is transformed to trapezium A. So P is transformed to trapezium A under translation. Always remember, in translation, what happens? The size never changes. Okay. Like whatever the size of trapezium P would be, that size of trapezium A is also going to be the same. Only difference is that the position would change. Maybe now the trapezium A will be somewhere over here, right? Originally P was over here and now A would be in this situation. So translation means that only changing position, size will not change. Let me write it down over here in notes that translation indicates change in position. Yeah, only change in position. Another thing, translation always comes with an equation, which is vector is equals to image minus object. Okay, this is vector equals to image minus object. If there is any question, guys, please interrupt me and ask. No problem with that. Always, they're going to provide you with a vector. For example, this is the vector they're talking about. That your object, this is your object because originally P was there from the start. So this is your object and P was transformed to A. Right? You need to understand that which structure was there on the diagram at first. P was at first, so P was your object. P was transformed, P was modified to trapezium A. In that case, this is your image, right? Object obviously will be converted into an image. Under what condition? Using this vector. So if they want you to find out that on the grid, draw and label trapezium A, that means at first you have to calculate the on your coordinate, calculate for that coordinates for the image. So I'll write it down over here. Part B is going to be over here. Original equation was image minus object, right? But we want to find out the coordinate for the image. Trapezium A was image. So our equation will be a little modified and it will be image. I mean, modified means I'll just make image the subject of this equation, which is image is equals to vector plus object. Now, vector was already given to you, which was 2 minus 3, and object was 5, 1, 3, 2, 2, 2, 1, 1, right? So this is, I'll just write down the object first, 5, 1, 1 minute, 5, 1, 3, 2, 2, 2, 1, 1. And again, this has to be added with that 2 minus 3. But 2 minus 3 is not just one vector, okay? It will be same kind of vector for all the 4 coordinates. So you can write it once, or you can also write it 4 times. That is also same thing. Like you can just choose to write it once or 4 times. That is totally fine. I would suggest writing it once because it will not cost too much time. Now you're going to add this 2 minus 3 with all the 4 coordinates of the object, which is 2 plus 5 is going to be 7. 2 plus 3, 5. 2 plus 2, 4. 2 plus 1, 3. Right, so you're going to get for all the x-axis 5, 7, 5, 4, 3. And for all the y-axis, it will be minus 3 minus plus 1. So it's going to be minus 2. Minus 3 plus 2 is going to be minus 1, minus 1, minus 2. Right, so these are the coordinates for your triangle A. Now using these coordinates, you have to draw this on the grid. So as I have to draw this on the grid, so what I will do is that I'll erase all these things. That's why I already made a copy of all these things at the very start, because I know I would have to erase these things. But on your graph paper, you cannot obviously do that, right? What you do is that on your graph paper, you have to keep on that lines, and on top of that line, you have to draw your another diagram. 7 minus 2. So it starts with 7 minus 2, this one. Okay. And then 5 minus 1. 5 minus 1. Then I think it was 4 minus 1. And 1 minute. 3 minus 2. Right. 3 minus 2. Right. So this is your triangle. Sorry, trapezium A then. Is there any problem for the working of part B? Is this clear? Himika, Isfa, Anaf, any questions? Are you guys even in the class? Okay. Also, Himika, are you feeling a little bit better now? Or you're still sick? Clear as water. Thank you. And Isfa, are you in class? I think Isfa somewhere in between leave the class and then she's not in here.
Suppose
Achha, she's there. Okay, sorry. Yes. Yeah, this was the working for part B then. We'll move on to part C. I truly believe that too, Anna. I'm with you. Okay, now it says that trapezium P is transformed to trapezium B under the rotation of 90-degree clockwise about the point 52. Right. Uh, on the grid, draw and label trapezium B. Now over here, for this kind of cases, when they're going to rotate the entire diagram, rotate means think of it like this. This was your original diagram. I don't know in what cases I can actually use a rotation in this tab also. 1 minute. Yeah. Okay. This, if I'm going to rotate this 90-degree, you can clearly see, right? This is 0-degree. If you're going to rotate this 90-degree, this is how the diagram would look like, right? I think on the screen you can see this is 0-degree and this is 90-degree rotation. But problem is this is a rotation exactly on that same point, from that same point, right? The position is not changing. On my diagram that I'm showing you to all of you, over here, the position is not changing. One minute. The position is same, it's just rotating about the fixed point. This is 0-degree it is going to rotate about the fixed point. But problem over here is that on your question for part C, it is saying that it was rotating about the center 5, 2. So rotation was not at the same point or was not from the center. This is from a point 5, 2. For this kind of cases, I always suggest you do a maths for this, okay? And I know this is just 2 marks, but I'm going to show you a very lengthy process, but it will be 100% sure and you're not going to create any mistake. Most of these students, what they do is that they will use their diagrams. Okay, they were saying that P was transformed to B, right? That means again, P is the object and B is now the new image over here. And it was transformed by a rotation of 90-degree clockwise from the point 52. Okay, so let's just first find out the what point 52 was. 52 is this position. This is the center. And with this center, the object was supposed to be rotated in a clockwise direction. Always remember, clockwise is in the direction in which the clock moves, right? This is the clockwise direction. So in that case, if you're going to create a rotation with 90-degree clockwise direction about this point, right? Then how your object is supposed to move? This is supposed to move in this direction, right? And how can you find out the coordinates from this point? That will be, for example, it always has to be in 90-degree clockwise, right? That means if your original diagram was, let me just copy this. If this is the structure of your original diagram, 1 minute. Okay, I mean, I'll just keep it like over this. So if the structure of your original diagram is like this, when you're going to rotate, like if you're going to take this position over here and rotate it in clockwise direction, wait 1 minute. Yeah, I mean, okay, just keep it over here. If you're going to rotate this in clockwise direction, this is how your object is supposed to look like, right? You can clearly see the previous one was horizontal and now this is in a vertical position. So this is how the new image will also be, but according to this point, but with this center. So in that case, what you have to do is that you have to first change this. You have to draw this point on this part and then rotate it in clockwise direction. For example, there are 2 units, so it will also be rotated in clockwise direction about that point. So this original was 3 2. Now it will be on like 5 this direction, right? Then it will be anti-clockwise. We're going to change this. It has to be in clockwise direction. Then this is the position. This it will be over here. But then again, it becomes extremely tough to understand that in which direction you have to move in. You have to focus on all the 4 points of this trapezium. So what I suggest, you do not use this approximation method. You calculate it using your mathematical procedures. Okay, you can obviously draw this using this part. For example, this again will be transformed to this point. This will be transformed to this point, and there'll be a point over here. So this is how you're going to create a diagram. This is your triangle B. But I think it will be tough for all of you to understand that exactly how it got reflected. You can clearly see, obviously, they were creating 90-degree in between, but sometimes this approximation method can certainly create some mistakes, right? So I would suggest draw, like first find out the coordinates and then draw that particular B. So I'll explain the other procedure. Okay, this one was, I know, quite confusing. I'll explain the other procedure. 1 minute. Actually, there's Ajan in my side, so I'm just going to turn off my mic for a few minutes. I'll stop when the prayer ends, I'll start again. Okay, so we will start again. Now, this was the statement which was provided in your question, right? That trapezium P was transformed to trapezium B under 90-degree clockwise, and the center was 5 2. Now, for this 90-degree clockwise, you have the particular matrix available. Okay, I think on your formula booklet again, there's a list of table where you can find out the particular matrix for every rotation. Okay, you have to memorize that again. I think there are 8 rotation. For every different rotation, you're going to get every different combination of matrix. So you have to memorize that entirely. So for 90-degree clockwise, the matrix was 0, 1, -1, 0. 0, 1, minus 1, 0, right. This was the matrix for the 90-degree clockwise rotation. And problem over here is that the center was not 0, 0, right? This time the center was 5, 2. So what first we have to do is that trapezium P, the coordinate for trapezium P, this was the coordinate from trapezium P. Now this was calculated with respect to the origin, right? But the rotation over here was not occurring with respect to the origin. The rotation over here is occurring because of the, like, with respect to the new center. So you also have to find out the coordinate of the trapezium with respect to the new center. So how can you find that out? So first thing first, there are going to be 3 steps over here, okay? First thing is that we're going to find out the coordinate of trapezium P, coordinate of the object with respect to the new center. So coordinate trapezium P, I'll just write sorry, with respect to new center, which was 5, 2, right? And what I will do over here is that the original coordinates were 5, 1, 3, 2, 2, 1, sorry. And then I guess 1, 1 it was. Yeah, 1, 1. So it'll be 2, 2. 1, 1. Okay. And I'm going to subtract the new center from this original coordinate. So if I subtract it, it's going to be 5, 2. Okay, and obviously I'm going to subtract this 5, 2 from all the 4 coordinates, but I'm going to write it only one time. And this will give you 5 minus 5 is 0, minus 1. 3 minus 5 is minus 2, 0. 2 minus 5 is minus 3, 0. This is going to be minus 4, minus 1, right? Now, this is the new coordinate for trapezium P with respect to the new center. Now, we're going to find out the coordinate for the image trapezium B with respect to the new center again, okay? For that case, what I'll do that is just that I'll multiply this coordinate with that 90-degree clockwise matrix to find out the value for your coordinate of trapezium B. But that will only give you the coordinate of the trapezium B with respect to the new center, because you are using this coordinate, right? This coordinate was in respect with the new center 5, 2. So for the next part, we're going to calculate coordinate will be coordinate of trapezium B. This is for image. Sorry. Image. What you're going to do is that image is equals to matrix multiplied with object. This is another formula, right? Whenever you have rotations involved, this is the formula you're going to use. Matrix multiplied with object give you that image. Now this is going to be, matrix was, we already know, 0, 1, minus 1, 0. And the new coordinate with respect to the new center was 0, minus 1, minus 2, 0, minus 3, 0, minus 4. I think this was also minus 1, right? Minus 1. And now you're going to multiply this. For example, first row, first column. What that will be? 0 into 0 is 0. 1 into minus 1 is minus 1. So first is minus 1. And then again, first row, second column. 0 into 2 is 0. 1 into 0 is 0. First row, third column. That is 0 into 3 is 0. 1 into 0 is 0. And then this and this is just going to be minus 1. 4 into 0 is 0. And 1 into minus 1 is just minus 1. So this is again minus 1. Similarly, second row, first column, that will be minus 1, 0, 0, minus 1, so 0. First row, second column, minus 1 into 2 is 0, 0 into 0 is just 0. Second row, third column, 1 into 3 is positive 3, and 0 into 0 is 0. So it's just going to be 3 over here. And 1 into 4 is 0, 0 into 1 is 0. So this is the coordinate. I think this is the coordinate that you got of trapezium B with respect to the new center, right? But on your graph paper, when you're going to draw trapezium B, you cannot draw this coordinate. You again have to find out the coordinate of trapezium B with respect to the origin center center. So what we're supposed to do at this point, whatever the amount that you subtracted from the trapezium P, from that object, you're just going to add that over here, 5, 2. Okay, you subtracted 5, 2 from trapezium P, and now finally you're going to add that over here. So which will be 5 minus 1. When minus 1, 4 is going to be minus 1, 5 is going to be 4, 5, 5, 4, and then it's 2, 2, 5, 2. Right, let me write this again. This one over here gives you the coordinates of trapezium B with respect to the center 5, 2. Okay. In order to find out the coordinate of the trapezium with center 0, 0, you're going to add that new, that original center you subtracted from the trapezium P. And now this one gives you the coordinates of the trapezium B with respect to the center 0, 0. And this is what you're going to draw on your graph, right? This coordinate 4, 2, 5, 2, 5, 5, 4, 2. Is this clear? Any questions for this part? Wait, actually, I think I made a mistake. 1 minute. This one and this one are supposed to be 1 into 4 is 4. Sorry, 1 minute. This was supposed to be positive 4 over here. I actually made a mistake. Sorry. Supposed to be 4, positive 4. So if this is positive 4, then this was supposed to be 6. Okay, 4, 6. Okay. So I'll just now go to your graph. I forgot the coordinate. 1 minute. 4, 2, 5, 2, 5, 5, 4, 6. Okay. 4, 2, 5, 2, 5, 2, and 4, 6. 1 minute. If I'm making any mistake on that, let me just check. 1 minute. This was 1, 0, 0 minus 1, this and this. Yeah, okay, 1 minute. There's supposed to be again 2 over here because minus 1, minus 2 is supposed to be positive 2. 0 and 0 is 0. But this is supposed to be positive 2. So 2 and 2 is this one will be 4. Sorry. 2 and 4 over here. Right. Then 4, 2, 5, 4, 5, 5, 4, 6. Sorry. I'll just write down the coordinates for here. It was 4, 2, 5, 5, 4, 2, 5, 5, then 5, 4, this one, and then again 4, 6, this one, right? This is how the image will be. This is the trapezium B, right? So I think, and also you have to measure, I mean, like, you have to point out that center, which was, sorry, 5, 2, not 6, 2. This was the center. Right? You have to point out that center also, like with this respect, everything was rotated. Is this clear to all of you? Like how we're going to find out the coordinates of this matrix whenever they're going to rotate with where the center is not 0, 0. When the center is different, this has to be done. But if the center was 0, 0, right, you could have just found out the final coordinate of the image by just using this procedure. Image into object, like matrix into object, will give you the coordinate of the image if the center was 0, 0. Like rotation was respect, if the rotation was doing with respect to the center 0, 0, then only this portion would be used. Okay, nothing other than that addition and multiplication would have to be done. Over here, the extra subtraction and then again multiply, adding this at the very end of your answer is only because your rotation was not occurring from the center; it was occurring from a new center. That's why this procedure has to be done. Is this clear? Any questions for this part C? Yes, Anna, please ask. Okay. Then we are going to move. It says that trapezium C is the image of trapezium Q under the transformation with matrix M, and this is the matrix. And on the grid, draw and label trapezium Q. Okay. Now, one thing I mean, it is not needed over here, but I'll still explain that over here, if you just take half common, right, then this is how the entire matrix will look: 0, minus 1, 1, 0. And this is exactly, this is the same matrix for your 0, minus 1, 1, 0. This is for 90-degree anti-clockwise, it centers 0, 0. Okay, this one indicates this matrix combination over here, half with 0, minus 1, 1, 0. This one indicates that half is your scale factor. Okay, there was a scale factor of half, and 0 minus 1 1 0. This matrix now indicates that triangle C was actually an image of triangle Q under the rotation of 90-degree anti-clockwise with scale factor half, and center was 0 0. That is what this entire half 0 minus 1 1 0 indicates. So half is scale factor, and this 0 minus 1 1 0 is 90-degree anti-clockwise. Even this was not needed, but as we are on in explaining everything in much detail, so I'm obviously going to explain a few things extra over here. So what this indicates is trapezium C is image of trapezium Q under 90-degree under the rotation of, sorry, under the rotation of, let me just write these things, under the rotation of 90-degree anti-clockwise, center 0 0 with scale factor half. Okay, this is how what this indicates, but this was not anywhere needed for your question. Okay, this is entirely extra. We just have to find out the coordinate of trapezium Q C, which is just image. Sorry, image is equals to matrix into object. That is only what we need to do over here. So for that case, I'll just scroll back to the very bottom. For part D now, image is your trapezium C. Okay, and matrix was given, and object was your trapezium Q. So matrix was 0, minus half, positive half, 0. And you're going to multiply this with the object. If I go up, I need the coordinates of Q, 4, 4, 0, 6, minus 2, 6, and minus 4, 4. Okay. So this is 4, 4, 0, 6, minus 2, 4, I think minus 2, 6, and then 4, 4, right? Minus 4, 4. Always remember that this is actually a 2 into 2 matrix, and this is a 2 into 4 matrix because they have 4 rows, right? This is 2 into 2, 2 into 4. Always write that 2 into 2 matrix first and 2 into 4 because it's easier for you to do this multiplication. First row, first column, first row, second column, like that. So in that case, 0 into 4 is 0, half into 4 is 2, minus 2. So it's just going to be minus 3, minus 3, minus 2, and then half into 4 is 2, 0, 1, 4, 0, 1, and then again minus 2, right? This is the coordinate for your triangle trapezium C. Okay, I'll just write it down over here. This is for trapezium C. Now what? Minus 2, 2, minus 3, 0, minus 3, 1, and minus 2, 2. Wait 1 minute. 1 minute, please. This is supposed to be -1. Hmm. Now we'll draw this coordinate again on your triangle, on your graph. So you have -2, -2, right? -2 is over here. And then -3, -1, -3, -1, -3, 0. And then you get -2, 2. This is C. Okay, Anaf and Isfa both left. It's just so nice of them. Other than that, Himika, do you have any problem? Okay, then we are done with one maths. Now again, obviously I took 1 hour to solve this one maths because I was explaining so much with much detail. That's why it took a lot of time, right? But in the next maths, we will not take this much time. Okay. So I think within this class, we can solve another question, question 2. So let's start with that, okay? Okay, now in this question, their points are given in centimeter. They have provided a grid also, right? It has already stated that the point with coordinates 1, 1, 2, 4, 4, 6, 3, 3 are vertices of a quadrilateral A. Now you need to draw this on the opposite grid. Like in the previous question, the diagram was already provided. This time they're not going to spoon fed you everything. You need to draw this on your grid. Okay, so 1, 1, 2, 4, 1, 1, 2, 4. The other coordinates were 4, 6, 3, 3. Okay. So 4, 6, 3, 3. Okay, yeah. This is how the quadrilateral looks. I need to use my auto correction now. This is entirely your quadrilateral A. This is your quadrilateral A. Okay. After this, it was stated that quadrilateral A is transformed to quadrilateral B under 90-degree anti-clockwise. We already know the matrix for this. That was 0, -1, 1, 0, right? We already did that in the last part. About the origin, this time you can see the center was 0, 0, right? If the center is 0, 0, you do not need to do any kind of subtraction addition. Now you can just use the equation image is equals to matrix multiplied with object. You need to identify which one was your image, which one was your object. Like A was there first and then B comes, right? So obviously A is your object and B is your image. And we need to draw a triangle, like, sorry, quadrilateral B on the diagram. But obviously we'll have to do the working first. So I'll do the working over here. That image, which was quadrilateral B, is going to be 0, -1, 1, 0, multiplied with quadrilateral A, which was 1, 1, 2, 4, 4, 6, 3, 3. So I'll just write 1, 1, 2, 4, 4, 6, 3, 3. I hope, Himika, you're understanding all these things, right? Himika, if you have any problem, please reply. Okay, thank you. Sorry. This is the coordinate for your triangle, trapezium B. Okay, so quadrilateral B. My wrong. Quadrilateral B. I'm going to draw this again on the grid. -1, 1, and then -4, 2, -6, 4, -3, 3. Similarly, I have to connect all the points together now. This is for quadrilateral B. Okay. Now after this, it is saying that quadrilateral B is again transformed to C under the transformation with matrix M, where this is a matrix. And now you need to find out triangle quadrilateral C. Similar working, right? Nothing else to do over here. Yeah, same working. We're just going to for C image this time. Quadrilateral C is your image, right? So C matrix already given 1 3 1 1. This is not any kind of rotation, so we cannot extract any matrix from this. Okay, 1 3 1 1 is just 1 3 1 1. This will be multiplied with that minus 1 1 minus 4 2 minus 6 4 minus 3 3. So if you add all this, minus 1 is minus 1, 3 into 1 is 3, so this is going to be 2. Minus 1 minus 4, and 1 into 4 is minus 4, and 3 into 2 is 6. This is going to be 2. Okay, then 1 into the minus 6, and this is 12. Then again, this is going to be 6, 3, 9. This is going to be again 6, right? Yeah. And 1, 1 is minus 1, 1. This is going to be 0. 1 to 4 is minus 4 and this will be 2, so minus 2. And then 1 minus 6, 4 is going to be minus 2. Minus 3, 3 is again going to be 0. So this is the coordinate of quadrilateral C. 2, 0, 2 minus 2, 6 minus 2, 6, 0. 2, 0, 2 minus 2, 6 minus 2, and 6, 0. Oh, wait. Yeah, 2, 0. X-axis 2 minus 2. Then you have 6, 0, and then 6 minus 2. Oh, now this is going to create a different shape actually. But this is an entire square this time. The other cases, it was like, a slightly parallelogram diagram. And now this is an entire square they're creating. So this is your quadrilateral C, right? That is it done. After this, we are going to move on. It says that calculate the determinant of the matrix M. Now you can easily find out the determinant using the formula that 1 minus like AD minus BC. That was the formula. For example, in this case, 1 3 1 1, right? This was in the format of A, B, C, D. For determinant, formula is AD minus BC. This is the formula. Okay, that's just it. According to your maths, the value for A was 1, D was 1, B was 3, C was 1, which is basically 1 minus 3, that is minus 2. So you can write this as determinant of M. Right? Det bracket M will give you the determinant of M. So this is 1 minute. It's just some processing happening. Wait, okay. So I'll just carry this and write it at the very end because this was the working for your part D. Okay. Yeah, I'll just write it down over here. This is the working for your part D, determinant of matrix M. And after that, it says that calculate the area of quadrilateral A. Okay. In area calculation, you can do that using the normal calculating area, right? Yeah. For quadrilateral A, you can just use that formula of area to calculate that. Wait 1 minute. Yeah, I mean, quadrilateral A is not like a proportionality, like an equal diagram, right? So you cannot use any other cases of a formula. I think using that equation with coordinate geometry that I taught is easier over here. Coordinates are 1, 1. Let me just see what the coordinates 1, 1, 2, 4, 4, 6, 3, 3. Okay. 1, 1, 2, 4, 4, 6. 1, 1, 2, 4, 4, 6. Wait, let me just go back again. 11244633. Okay, 33. Now the formula was this: area half modulus 1 1 2 4 3 and then again 1, because you remember x1 x2. Wait 1 minute, I think I wrote it a bit more. 1 2 4 3 1, like x1 x2 x3 x4 and then again x1. Then y1 was 1 4 6 3 1, like y1 y2 y3 y4 and then again y1. And obviously we're using modulus because area is a scalar quantity. Now it will be half modulus. We are first going to multiply it in this direction, which is 4 into 1 is 4, 12. 4 into 3 is also 12, and this is again 3. And we're going to subtract it with this direction, which is going to be 1 into 2 is 2, 4 into 4 is 16, 3 into 12, 3 into 6 is 18, 3 into 1 is 6. Put everything inside the modulus. So inside the brackets, you now have 4, 12, 12, 3. That is 31 for the first bracket. And 2, sorry, 2, 16, 18, 6. 2, 16, 2, 16, 18, 6. That is 42. Okay. So now you have 0.5 modulus 31 minus 42 modulus, which is basically 31 minus 42 is certainly negative, but as they have modulus, everything outside the modulus will be positive. So that 11 with half will become 5.5. Okay. Area, volume, these are scalar quantities. They can never be negative. It will be 5.5 units square. Himika, is this clear to you? Okay. Now, I'll just turn off the recording first.